Okay, so today we're practicing the first derivative test. Okay, so for these first couple problems, we're going to do the following. We're going to find the critical numbers, we're going to find the open intervals where the function is increasing and decreasing, and then we're going to apply that first derivative test to identify all relative extrema. Okay, so for this first problem, okay, the steps to find critical points is to take the derivative of our function and then set it equal to 0, and those will give us our critical points, wherever the derivative is 0 or undefined. Well, this function here is never going to be undefined when we take the derivative, so we just have to worry about the zeros. So let's start by taking the derivative. Now, you could, if you wanted to, take the time to FOIL this all out, but it's easier just to do the derivative using product rule and having a chain rule. So taking the derivative first is chain rule, so it's 2 times x plus 2 to the first power times the derivative of the inside, which is 1, times x minus 1, plus the derivative of x minus 1, which is 1, and then I have x plus 2 squared. Now, I got to simplify this a little bit, but I'm going to be setting this equal to 0. Now, if you notice, both of these have an x plus 2 and an x plus 2, so I can factor out the x plus 2, and in this first part, I'm left with 2 times x minus 1, which is 2x minus 2, and then in the other one, I'm going to be left with x plus 2, like that. So when I factor it, I get that, and then I get x plus 2, and when you take 2x plus another x, you get 3x, and negative 2 plus 2 is 0, so you get 3x, which makes me finding my critical points really easy, which are negative 2 and x equals 0. Okay, so those are my critical numbers. That's part A. Right here. This is part A. Critical numbers. Then part B. Okay, so I'm going to set up my number line with my critical numbers on it, which are negative 2 is a 0 and 0 is a 0. And I'm going to do my first derivative test here. Now I'm kind of doing B and C at the exact same time. Okay, so these are where our derivative is 0. Okay, so then I plug in negative 3. And when I plug in negative 3 into my derivative, which I use this one right here, when I plug negative 3, I'm going to get a negative for the first one, a negative for the second one, so a negative times a negative is positive here. And then you're going to plug in negative 1 and do the same thing. It's going to be a positive times a negative, which is negative there. And then plug in positive 1 and you get a positive. Okay? So for part B, my function is increasing from negative infinity to negative 3, and from, sorry, this is negative 2, and then from 0 to infinity. So that's where it's increasing. It's decreasing between negative 2 and 0. And notice I didn't include any of the critical numbers. They're all open intervals. So that's part B. And then part C says identify the relative extrema. So we're going to apply, this is basically the first derivative test. Since this is my 0, my critical point, where my horizontal tangent is, on this side my function's increasing up to this point, and then on the other side it's decreasing. So that means that negative 2 is a relative maximum. And then this one, where my horizontal tangent is 0, I'm decreasing this side, but then increase on the other side, so that means that this one is a relative minimum, and that's part C. So you see how basically all of these parts together work to find my critical numbers, my increasing, my decreasing, and my relative extrema all at the same time. Okay, because I can't find my critical numbers and not find and then be able to do my first derivative test. I find where my function is increasing and decreasing in my first derivative test in order to find my maximums and minimums. I can't tell that this is a maximum until I find that on this side my derivative is positive, which means my function is increasing, and on this side it is decreasing. So I can't find part C without finding part B's values. Okay? Now, we're going to do the same thing, but this time it's going to be a little different because I have a piecewise function. But we start off the same way. So we find the derivative, g prime. So I find the derivative of both pieces separately. So the derivative of 2x plus 1 is 2, and that's when x is less than or equal to negative 1. And then here, I take the derivative of x squared minus 2, which is 2x, and that's when x is greater than or equal to 1. Now, you're finding critical points in a function where the derivative is either equal to 0 or my derivative is undefined. And my derivative is undefined wherever it's not smooth or continuous as well. So you got to check where it's not smooth or continuous, where it is got a vertical tangent, or where it's not smooth, where either at a cusp or something like that. So basically, when I look at this part here, if I plug in g of negative 1, I look at negative 1. When I plug in negative 1 into my top function here, I'm going to get negative 2 plus 1, which is negative 1. When I plug negative 1 into my second part, okay, I get 1 minus 2, which is negative 1. So it's continuous at negative 1. But when I look at here, the slopes, here my slope is 2 at negative 1. But on the other side, when I plug in negative 1 into x, I get negative 2, which means my slope goes from positive 2 to negative 2. That's telling me that my function is not smooth there, which means the derivative is therefore not defined. So that is also going to be a critical point. So x equals negative 1 is a critical point. And, of course, when I set this equal to 0, I get x equals 0 as a critical point. Okay? So again, those are my critical numbers. That's part A. Part B is doing my number line. So I set up my number line. I'm going to put in negative 1, put in 0. Okay, negative 1 is where it's undefined. 0 is my 0. Okay, so then I plug in points to find my increasing and decreasing. So on this side of negative 1, this is where it's less than negative 1. My slope is right here, 2. So it's positive there. Then I look at negative 1/2. Okay? Well, negative 1/2 is greater. So when I put a negative 1/2 into the second part, I get a negative slope because 2 times negative 1/2 is negative 1. Then I put in, say, 1, and I get positive 2 slope. So here it is positive again. Okay? So when we look at this, again, my horizontal tangent is here, and my function goes from decreasing to increasing. So this is a minimum. This one here, it goes from increasing to decreasing, so this is a maximum. Okay? And then again, part B, if you're writing it, my function is increasing from negative infinity to negative 1, and it's increasing from 0 to infinity. It's decreasing only from negative 1 to 0. Okay? Now, these are relative extrema. So these are not absolute extrema. And the reason they're not absolute extrema is because we are not on a closed interval here. But on these next couple problems, we're looking at them on a closed interval. So we are going to be looking for the absolute extrema. Okay? So, number 3, basically, to do absolute value functions, you have to set them up as a piecewise. So 1 is going to be exactly how it's written. So this one, and the other one is going to be the opposite sign, like this. So we're in front of the absolute value, one's going to be whatever sign it has, and one's going to be the opposite. Now, this one is going to be when t is greater than 3, and this one is going to be when t is less than 3. Okay? Now, we find the derivative, y prime. So the derivative of the top one, oh, hold on, let's rewrite, just so it's easier. Okay? Because I know that if I skip this step, I'm going to lose some of you guys. Okay? So let's rewrite. So when I rewrite the top one, I get 6 minus t, and the bottom one is just going to be t, and this is when t is greater than 3, and this one's going to be when t is less than 3. And I'll make that one equal to, just whatever. Now we find the derivative. So y prime. The derivative of the top one is going to be -1, and the derivative of the bottom one is going to be 1. And this is when t is greater than or equal to 3, and this is when t is less than 3. And again, because here at 3, I don't have any critical points because you set these equal to 0, there's no zeros of the first derivative, but because this changes slope from -1 to +1, that means that it's not smooth there. There's a point there. The slope doesn't smoothly change or exactly the same here. So that is a critical point at 3. So t equals 3 is a critical point. It's the only critical point I have because the derivative is undefined there. But since we're looking for absolute, we also have to test our endpoints. So first we're going to put in -1. Or we could do 3. So when we plug in 3 into our equation, so 3 minus the absolute value of 3 minus 3, you're going to get 3. And then same thing, y, plugging in -1. So we get 3 minus -1 minus 3. So that's -4, +4, 3 minus 4, which is -1. And then the last one, we plug in 5, so we get 5 minus 3. So 5 minus 3 is 2, and 3 minus 2 is 1. Okay? So that means that this one right here, t equals 3, is my absolute maximum. It's highest value. I get to a height of 3. This one right here, where t equals -1, that is my absolute minimum. Okay? All right, now the last one. So, again, how do you got to find critical points, and then you check the endpoints since we're looking for absolutes. So to find critical points, we find the derivative, which is 6x squared minus 6. Set it equal to 0. And we get, move the 6 over, so we get x squared equals 1, which means x equals plus or minus 1. Okay? And then we set up our number line. So -1 and 1. Those are my zeros. So checking my critical points to see if these are maximums or minimums. So when you plug in -2, we get positive. We plug in 0, we get negative. When we plug in 2, we get positive, which means that this one goes from increasing to decreasing, and this one goes from decreasing to increasing. So this is a relative max, and this is a relative min. Now, there's only one problem. We can't use -1. We can't use -1 because our intervals only from 0 to 3. So we cannot use this one. That is not going to be something that I can use. So basically I can use 1, and we know that that's a relative min, but we don't know if it's our absolute min. So first thing we're going to do is we're going to plug in, find h at 1. Well, when we plug in h at 1, we get -4, because it's going to be 2 minus 6, which is -4. Now we check our endpoints. When we plug in 0, we get 0. And then we plug in 3, and we get 36. You're going to get 54 minus 18, which is 36. Which means that, in fact, that relative min is our absolute minimum. And our endpoint 3, that is our absolute maximum. So you got to be careful. Sometimes our critical points aren't in the domain that we're dealing with, so we have to make sure that we exclude those when we're doing it. And that is Extrema.